Good morning, good evening, good afternoon, and thank you all for attending the 12th meeting of 2019 for Bitcoin Cash developers. I'm going to start today's meeting with a introduction by each of you, and we'll start with Mark Lundeberg, who is sitting on my top left.
Hi, I'm Mark Lundeberg. I'm a Bitcoin Cash developer. I'm working on the, I guess I'm the main person working on the next upgrade and designing it.
Great, thank you, Mark. Amaury, if you could introduce yourself, please.
I'm Amaury. I'm a lead developer of Bitcoin ABC.
Thank you, Amaury. Emil?
Hi, my name is Emil. My name is Emil Oldenburg. I'm the CTO for Bitcoin.com. Bitcoin.com represents the Bitcoin.com mining pool and Better Wallets.
Okay, thank you, Emil. Your microphone is, your connection was a little bit off, but I think we got it okay. Next is Jason B. Cox.
Okay.
Hi, I'm Jason Cox, software engineer contributing to Bitcoin ABC.
Right. Thank you, Jason. Antony?
I'm Antony Zegers, also known as Mangarian, and I just work on various Bitcoin Cash stuff.
Great, thank you, Antony. And Andrea Suisani.
Hi everyone, I'm Andrea, Bitcoin Unlimited developer.
Okay, thank you. And we'll move on to the items on our agenda today. The first general topic is the discussion of the upgrade timeline and the items. So I'll just quickly go over the 5 items we have on the list, or 4 items we have on the list, and then we'll come back and deal with each of them. So number A is feature freeze for Bitcoin ABC is August 15th. Number B is update on Schnorr for CHECKMULTISIG. Number C is minimal data. Number D is draft specifications are up for review at bitcoincash.org on GitHub. And so we'll start with the feature freeze for Bitcoin ABC being August the 15th. Anyone like to speak to that?
Yeah, I can talk about that.
Thank you.
So same with the last 2 upgrades. I know Mark is working really hard on getting the minimal data and Schnorr changes in to get it in on time. I think that's pretty much it.
I guess I'll just throw in a comment also, basically, just that like August 15th is when we want to have everything like completed and ready. So pretty much anything that's not already in progress right now, like you can't, it's probably too late to try to start doing something. So I guess Mark's stuff is the main thing that seems to be on track at this point.
Yeah, but that shouldn't discourage anyone from continuing work on changes to go into future upgrades. Like there's no reason to wait until the next upgrade is deployed to start working on the next one.
Good. Any other comments about the feature freeze? All right, move on to the next item, which is, of course, Mark with the update on Schnorr.
The Schnorr and CHECKMULTISIG, yeah. Yeah, so we covered that last time. This is just to summarize again, this is a continuation of what we did in the last upgrade, and just make sure that all of the signature checking opcodes can use Schnorr signatures. And we're trying to do it in an intelligent way that makes CHECKMULTISIG a little bit more efficient than the current design, which has some flaws. So if anyone's been following closely about the specification of that opcode, there's one change that looks like we'll make, which is in the bit field that we're using to specify which signatures go with which pub keys. We're probably going to change the way that's encoded so that it matches a little bit better with the bit field idea, and it works a little bit better with the bit field manipulation opcodes that we have. So up and, up or, up XOR. just in case smart contract designers might want to do something fancy with that. We'll try to make it just the best possible. But otherwise, yeah, the spec as is pretty much the plan. And yeah.
Thank you, Mark. Any comments, or anybody would like to make any comments with regard to what Mark just said? No. All right, move on to the next item, which has Mark's name beside it, which is minimal data.
Yeah, so this is the other item that looks like it'll be in the upgrade, is just turning on the minimal data flag that's already been standard for years now. And this is sort of like the final of a long series of malleability fixes for the existing transactions, just to make sure that most transactions that you do can't be malleated by a malicious miner. And yeah, so I think most code bases have this programmed in already because it is a standardness rule. But since it's going to be converted to consensus, there is a proper specification that's up. And we encourage all implementations to import the C++ clients test vectors, just to make sure that they get all the corner cases right, because there are some tricky parts of every rule, even something as simple as this minimal data. So, yeah.
Okay. Any further comments from anyone on the panel?
Not really. I guess just to clarify, like, so it'll definitely make all pay to public key hash transactions non-malleable. What about pay to script hash? Will it make all of them non-malleable too? Or is there a way?
No. There's always the way you, like, no matter how many malleability fixes you do, there's always people can do clever things to make a transaction where you can tweak the transaction ID. Right? And that's even the case on SegWit. You can sign with anyone can pay on the signatures, and then you can flip around the order of the inputs, for example, and that changes the transaction ID, even though nothing actually changed in the meaning of the transaction in some sense. So,
but for any like normal, I guess like for any pay to public key hash, it would be non-malleable.
Yes. Yes.
Any like P2SH that's just like a multisig standard.
Yeah. So with the multisig changes that will go in, this will interact nicely with, this will mesh in nicely with this minimal data. So it will mean that also the multisig should be non-malleable in the regular case.
So,
and if people are writing smart contracts, like fancy P2SH scripts, it should in principle always be possible to write it in such a way that it's non-malleable. But you have to be careful about using ob-if. There's various little things. So it might be tricky. You might make a mistake if you're writing such a smart contract and accidentally include a malleability mechanism. So it's not really perfect. It's not like foolproof for smart contracts, but it is what we want for the main classes of transactions, which are pay to public key hash and multisig.
which is just to get in.
Percent. Yeah.
What's that?
99% of transactions, I guess.
Okay.
I haven't actually looked at the statistics there. But
Yeah, that's what I was gonna ask. Like, what just to give a sense of what that is. Like, yeah, so it's probably like 99 or more % of transactions will be non-malleable or something.
Yeah.
Okay, any further comments on minimal data?
No.
Nope. Okay. Moving on to the next item on the agenda, which is draft specifications that are up for review on bitcoincash.org. Who would like to speak to that?
Well, I just wanted to mention that they're there and to encourage people to have a look and check them over and help make sure they're understandable and correct. So there wasn't much to say about them other than that.
Okay.
Yeah, more eyes on those specs prior to the feature freeze is definitely helpful.
Where can you find them?
BitcoinCash.org.
Yeah, is that on a pull request?
One of them was merged as a draft. So if you go into the spec directory, it's like the overall one for the upgrade is in the spec directory.
The November upgrade?
No, it says 2019 11 15. That's the prefix, and then it says upgrade. Like someone added the link here.
And I think that has linked to the pull request in the merged draft. I'm not sure.
Yeah, I see it.
Yeah.
Yeah, I was wondering if there's any progress on the. This is not a hard. So the non-hard fork features, such as allowing longer chains of unconfirmed transactions. There has been some work on that, but there were some issues, I believe, with the spec.
I'm not aware of there being a spec.
Yeah, well, it's very easy to write one. It's like one sentence. We want longer chains. Done.
I'm not so sure that qualifies as a spec, but I suppose we can take that conversation offline.
It's a very small, simple feature, so let's not make it too.
Yeah, no, I don't think there is a problem with the spec here, but it's like you got to realize that that limit is in place because of all the data flow across the whole software. This is a very, very significant refactoring.
Yeah, so like the goal is very easy to describe, but the path to get there is hard, and there are multiple ways of getting there. And I know Shama was working on one way that met some resistance. So which is the best path of getting there, you think?
So like there are multiple facets to that problem, but I'd say the biggest problem is not really the path. The biggest problem is that anything that we change, we cannot then backport from core, and we have to maintain ourselves. And in the current state of affairs, it's very difficult to take on more on that front. Now, if you want to talk about the path specifically, the best path to get there. So okay, let's explain where we are to begin with. The path doesn't make any sense. What's happening in the software right now is that the code is optimized to try to select the set of transactions that have the most fees in each block template, and it works that way because we inherited it from core that work in a way that assume that the mempool is very much full, and so you need to pick the right set of transactions that's gonna maximize the fee that you collect as a miner. This comes with a set of trade-offs that don't really make sense for us. And so what we would like to do, I think what makes the most sense for BCH is that we have the mempool, and effectively when we produce a block template, we don't do any kind of complicated computation. We just take everything that is in the mempool and serve it to the mining software as a block template. And removing all that computation also remove the needs for the limits, because the limits they are there because that computation without limits could end up being absurdly expensive. So if you remove the computation, you remove the need for the limit, so you can remove the limit. But that means that all the fee management, all the code that manage the fees and like minimum fees and stuff like that right now happen at a certain point in the software, and it needs to all be moved up front, right? So all that logic need to be moved before we accept something in the mempool, rather than
so instead of calculating the fees, it just first seen, first accept, like it just first seen, first mined. As long as it meets the
but so the computation is, so what is complex is that you want to select the transaction that have the that collect the most fee for you as a miner, but if you are like, if transaction depends on each other, right? So if maybe you have a transaction that have a very high fee, but in that case, you need to include all the parent of that transaction as well in the block, right? So you cannot just do the simple stuff that would be sort all the transaction by fee from highest fee to lower fee and use that. It doesn't quite work. So there is a very complicated algorithm that compute for each transaction, not just the fee that exists from that transaction, but it works with packages, try to create packages of transactions with their parent that maximize the overall fee that you get from the overall package and all the transactions that are in there. And it turns out that this algorithm is quadratic in the depth of number of parent of descendant that you have. But we are not really because our blocks are bigger than the mempool, we don't really need to run that algorithm at all, right? We would like to just take a snapshot of the mempool and set that. The thing is, we cannot remove every single fee management stuff. We need to we need to still be able to filter transactions that pay too low of a fee or whatever, because if we don't, then we open ourselves to various denial of attack and stuff like that. So right now there is a bunch of logic that is sprinkled in the acceptance to the mempool, and in the get block template construction. And you want to get rid of maybe 80% of it. And you want to make sure that the 20% of it that we actually need in our case are all moved upfront before the mempool, so we can clean up everything from the mempool and the block template construction. But yeah, but to look back, why it is a challenge, because it touched the block template construction, the mempool, and the acceptance of transaction. And so it's probably gonna touch the network layer a bit as well. It's really something that, go cross-layer across the whole application, because what the application does is take transactions, process them, validate them, put them in the mempool, package them into block templates, and send that to the miner. That's essentially what the software is doing, and changing that touch every single aspect of that. And this is why it's fairly challenging.
Okay, and we're planning to keep child pays for parent, because that is one of the things that's slowing things down, right?
Yeah, so I think it doesn't make sense to keep it the way it's implemented right now, right? Because the way it's implemented right now is to maximize fee in the block template construction. So that doesn't make a lot of sense. We want to make sure, though, that someone that receives a payment is able to send a transaction that higher of a fee. So say you receive a payment and the person doesn't pay enough of a fee for the transaction. You don't want that transaction to be stuck in limbo forever. This is very bad user experience for everybody. So you want the software to be able to send another transaction that, get the whole package to go through. But this doesn't need to be done via, very complex algorithm. You can do everything before the mempool acceptance. So what's going to happen is that you send the first transaction, and some nodes are going to reject it because the fee is too low, right? So those nodes, they are not going to accept that transaction. And then the child comes, and so the node that already accepted the parent, then, it's all good for them. They don't need to do anything special. The one that did not, they're going to see a transaction that a parent is missing, right? And what the node software does in that case is that it puts that transaction into what is called the Orphan pool. So those are a set of transactions that appears to be valid for all we know, but we don't have all the parents, right? So we cannot really bind them, but because we sometimes receive transactions of order, it's essentially a small pool where we can keep them for a while. And what this is doing, that the node requests the parents, from other third-party nodes. So you're gonna receive the parent again. And here is the piece that we are missing right now that we should have. It's like when you request the parent, so you reprocess the parent again, and you should notice that it pays too low of a fee again, right? So right now we just reject the whole chain that way. But what we should be doing instead is that when we get a transaction and we notice that it pays too low of a fee, instead of rejecting it outright, we go snoop into the Orphan pool. And it's like, okay, is there a descendant of that transaction in the Orphan pool? And if yes, you can compute the overall fee on the two transactions and accept the two transactions at once or not. And if you do that, you get all the benefit of child-free parent that we are interested in. And you can get rid of, you know, most of the complexity of it.
If I can just jump in. So the use case you have in mind here is something like BIP70 payment protocol where, you know, someone might pay to a merchant with a transaction that's too low fee, but the merchant wants to make sure that transaction can actually go through. So they'll pay for the remainder of the fee in essence,
Yep.
to make sure that it can actually reach the miners and get mined. Interesting. Okay. Yeah. So just to give.
Yeah, this is pretty much the only. This is pretty much the only situation where child pay for parent is interesting for us, right? So removing it completely would be a regression on that type of use case because you would end up with that transaction that is stuck in limbo, right? And the merchant doesn't know if it's gonna go through or not, right? But what's happening is that if we end up going through like an hour after, because one miner have, you know, the parameter set a bit differently, then the merchant is gonna have to refund the customer for some reason. So the whole stuff is very impractical in practice. So you need a way to, you know, you need to have a way to set that properly.
So I've been trying to follow some of these discussions and just to sort of give like my own take on it. One of the it is all sort of interconnected because one of the things you want to answer is if you do remove the tracking packages, then it influences the way that the mempool reacts when it gets flooded. So if somebody does a stress test or a STAM or something like this, currently what would happen is that it uses these packages to decide which transactions get dropped from the mempool because the mempool tries to maximize the amount of like fee density and tries to help the miners mine the most fee possible. And this makes a lot of sense when you have a small block size and you're overloaded. You do want to maximize the fee-paying transactions, of course. And if we do get rid of that logic, then there's a question, okay, what do we do then if we get a spam attack? What is the quality of service mechanism?
Yeah, so
you
in that
you
case,
can't just you can't keep taking mempool transactions forever because you're going to run out of RAM.
yeah, absolutely.
What do you do? Do you reject or do you eject?
Yeah, so there is this is another thing that we need to consider, and actually we need to reconsider it regardless of if we want to do this refactoring or not, because this is one way where zeroconf are not as secure as they should be, right? Yeah. Because right now you can make a transaction, and then if the mempool ends up being flooded with transactions that pay a bit higher of a fee, then the transaction that you think was accepted can end up being dropped out of the mempool. And so you don't want, like, when something is in the mempool, it is in the mempool. You don't want to, you don't want to reject it in any way. So what you want the node software to do is not reject stuff that are in the mempool, but say when the mempool is past a certain size, you may want to, ramp up the acceptance fee a bit, right? So when you are in the flood attack, then you would end up having a fee that is a bit higher, but only for new transactions that are coming. Existing ones that have been accepted already, you shouldn't reject them, right? So doing that at the mempool level is not the right, it's not the right place in the pipeline to do it. Because then you cannot pretend, like you cannot say to people, we have zero conf, and we accepted that if in some condition you can renege on that and decide to reject that transaction anyway. So yeah, that's a behavior, that's a current behavior of the software that is I think not right. And so this is something that we would have to fix also if we change that pipeline. But yeah, all of that come as a bundle, and there are other stuff that we can do if we change that. Is that we can have much more involved fee policies, right? So we can take coinage into account, for instance. So right now, if we want to start to take coinage into account, we have to modify, like, essentially the block template construction, the mempool management, and the acceptance of transaction into the mempool, right? So we need to, like, sprinkle that stuff everywhere, and it would be very risky because that code is actually quite fragile. And so if we clean everything up and we do everything up front, this is also very easy to change this kind of stuff. So there is a lot of good stuff that followed of that, but it's just a huge refactoring.
So, for example, you mean that if there was a spam attack, then we could have a scoring system for admitting new transactions after a certain threshold. It could look at the Coinbase destroyed and it could say, well, this looks like an honest transaction, so let's let it in, of course, because, this is.
So you can have heuristics, but you can just also say, okay, once the mempool is like sorry to make, which is the size of the block, then every so often we increase the fee, right? So past 32 meg, you can have something that is exponential or whatever that just ramp up the fee. And you can expect like fill up large amount of block with transaction that pay slightly higher of a fee, end up being very, very expensive for the attacker. If you choose the value properly, it's not that big of an issue for most users.
Yeah.
Because you're gonna pay like 1 cent instead of a fraction of a cent, right, for your transaction, which maybe for a micro payment, maybe it's an issue, but for most real world use case, it's still much lower than various fee for those systems.
Yeah, but in general, this follows a good ideology of you want to degrade gracefully as the node gets full, rather than having just a cutoff point where it's like, okay, after this, suddenly the usability of Bitcoin drops dramatically. Having graceful degradation is a good property to have.
Right.
I guess looping around back to the original question, though, this is ultimately about this 25 unconfirmed limit, and so it's interesting that all these issues do interplay into this.
Yeah, because all those issues really fall out from all the data flow across the whole software is working, and so you get a lot of benefit, but it's a huge amount of work, and also it's a work that prevents us to, or not completely prevent us, but it's gonna prevent us to backport some of the improvement that Core made since we forked in the code base. And so we probably want to make sure that we backport as much of those as possible before we actually change everything.
I had a question, Amaury, just about the idea. I'm just curious about, so if you just to basically take a snapshot of the mempool to make your block templates, what about miners who want to have a different policy? Like I know some miners are like, okay, I'm only mining, like I don't want to have 1 Satoshi per byte. I'll only mine stuff that's whatever, 5 Satoshis per byte or higher or something. So how would that work?
That's fine. They're gonna have a different mempool than everybody else, right?
Yeah, but then how would that work on the network? Like, would they be forwarding those transactions on, or I'm just kind of confused about how that would work, or I'm curious about how, because that would affect how they behave on the network then, right?
You mean that currently you can have a relay fee rate and a mining fee V8 that are different.
Yeah, yeah. Like currently they can relay them, but they don't mine them.
Yeah, yeah.
So would they then have them all in some kind of orphan pool and relay them? And I don't know. Maybe that's getting too into the weeds, but
Yeah, it probably is. At least with our previous discussions around Avalanche, I could see miners, mining only a portion of the mempool, and that would be totally fine. But if they start mining double spends, essentially implementing RBF, then that may be problematic in the future. But it would be up to them to configure their software correctly.
Well, I mean, the way we're talking about it, what Amaury is saying is you basically don't, it's not really possible to mine only a portion of the mempool. Right?
Well, you can have like a low fee pool or something like that. Right?
Yeah. Yeah. So you'd basically have.
Already, so one thing that people don't quite realize is that the mempool is just one of the pool of transactions that exist in the software. There are actually others, and I mentioned the Orphan pool, for instance, which is a pool of transaction where we don't have all the parents yet, or maybe maybe some of them are actually fake transactions, right? So we can have some of those pools that are like not in the main pipeline of the software, but that contains transactions that we want to have lying around because we're probably gonna need them going forward. And so we can perfectly introduce like a low fee pool that would be similar to the Orphan pool. And so that would be also a way to, when you receive something that is Orphan because the parent has a low fee, you can pick it back up from the low fee pool and do whatever CPFP computation at that point in time.
So I guess under normal conditions,
use them to forward transactions as well.
Yeah.
Right. So all of those stuff they have solutions.
Yeah. So say you had a low fee pool, I guess it would basically be kind of similar to how the mempool is now, but maybe say that got flooded with spam, then you could be more ruthless in throwing out the spam or something because not really.
Yeah, exactly. Those pool like the Orphan pool, for instance, is much smaller than the mempool, and the software is going to be much more ruthless about throwing stuff away from there.
Yeah. Right,
because it's just stuff that it's probably going to need going forward, but it's not a given. And anyway, if you lose it, you lose it, right? You can still re-request it from another node if it turns out that it's actually important. Mm-hmm. And we can do the same for the low fee pool, right? Those are low fee transactions. And so you can keep some of them lying around, and you can keep the pool big enough so that in normal modes of operation, you just keep whatever is in there and repeat. But if you get flooded or whatever, you can just stop dropping them. You don't intend to mine them anyway, right? You just want to relay them. Like as far as I understand, this is the use case that is brought up. You just want to relay them. So once you've relayed them, right, you don't need them anymore. So you don't need to keep them around for a very long time.
Mm-hmm.
It's kind of interesting though, because I think what Antony was suggesting was almost like the inverse of that. If you were a miner only interested in mining the high fee pool or the higher fee pool, which is basically the mempool minus the low fee pool, then you could actually do that and just mine any necessary parents out of the low fee pool. Is that what you're saying?
Well, you wouldn't have Orphan in the mempool, right? So that like the case that you explained just don't really make sense.
Wait, what do you mean?
But if you accept something in the mempool, you gotta have the parent in the mempool, right? Otherwise, you are accepting transactions that are invalid in the mempool.
Okay, so the low fee pool is only low fee transactions that do not have ancestors that pay high enough fee.
Yeah, so no, descendants. So if you end up receiving a descendant that pay high enough of a fee, you may end up promoting into the mempool, like pick stuff from the low fee pool and send them in the mempool. But you cannot send something in the mempool if the parents are not already in the mempool.
Got it.
Otherwise, otherwise you end up with something that would make sense. Or even worse, you end up having to track dependency across different pools and stuff like that. You don't want to be doing that. Like, it's exactly the kind of shit for which we need those 25 transaction limits and stuff like that to begin with, right? So you don't want to be doing this kind of gymnastic in the software.
So just getting back to the practical point. So if somebody did want to work on this and try to make some progress towards this new setup, what should they do? What should they start with?
Backports.
So backport is one of them. There is a second stuff. It's like the upfront acceptance is purely additive, right? You don't need to touch anything of the existing code to implement that, right? So you can implement that, test it properly.
This new
all the complex logic.
This new like de-orphaning or download parents if they're low fee type thing.
Yeah, the download parents actually already exists in the software. That's a feature that already exists.
Right.
But, yeah. So, but all those extra logic, like comparing the fees and stuff like that before you send stuff into the mempool, that can be implemented without touching any of the logic that is downstream.
Okay, so that's
once it's good enough, then we can start scrapping up, and it can happen in parallel of the backport because this is new logic.
Yeah. And for the scrapping of the old stuff, due to how it's all integrated, it's going to have to all happen at once in effect. Do you think, or no?
No, because like, you can
take up pieces one by one.
Yeah, you can gut, like for instance, the get block template. You can gut most of it and take a snapshot of the mempool, and then you would still be tracking, all those information in the mempool, but you end up not using it in the block template construction, right? And then you can deassemble them one by one. It's actually preferable to deassemble that stuff piece by piece rather than doing a giant monster change.
If there is a preferred way forward, then yeah, I guess if anyone's interested in doing this, I guess what would you say they should get in touch and try to see what the general picture is?
Yeah, though it doesn't seem like to me this is a task that you want to start with.
Right, it's not.
I mean, like, let's be serious. You need to have a reasonable grasp of the existing code base if you want to launch yourself into this.
Yes.
Because, this is affecting the data flow in the whole software. So if you don't have like a good grasp of what that data flow is to begin with, you are more likely to create more complication for everybody involved than anything else.
All right. Good discussion, guys. Just want to know if there's any other topics that anyone would like to bring forward before we wrap up. Andrea, did you have anything specific you wanted to bring forward today?
No, I don't have any. I just listened to what's going on under the development umbrella, and then it's a way for me and you to stay up to date, but nothing to bring.
All right, thank you. I just wanted to give you the chance to do that. Anyone else have anything they want to bring forward for general discussion?
I had something that's kind of a minor point, but if we have time,
Sure.
I could bring it up.
Yeah, go for it.
It just came up this week because I just wanted to talk about the seeders for the network, because just as background, one of the security assumptions of the system is that you get at least one good seeder, like a connection to the network. As long as you have a good one good connection, then the proof of work and all that should work. You won't be partitioned off. So to make that work, there's seeds in the software that you can connect to, and there's seeders, which are like a DNS server. It has a domain name that the software can connect to get lists of seeds. And right now there's a few of them run by, like, Bitcoin ABC runs one, Bitcoin Unlimited runs one, I think and there's a few. But Bitcoin ABC in the software, we've brought in the seeder, so there's a seeder in there when you download the software. And it's a very lightweight thing to run. It just kind of scans the network and collects a list of nodes that it can see. So I just wanted to throw the idea out there that it's a good idea if anyone feels like running a seeder. That would be a good thing to do. Like I think like large businesses would be a good thing that they could do. It's like extremely minimal in terms of resource usage. So maybe Bitcoin.com wants to run a seeder, or other people.
I think Bitcoin.com can run a couple without any problem. We like a 10 gigabit.
For all I know, maybe you have one already, and then if you have it, we can just add it into the software. It'd be nice to get a few more in there, just for the redundancy.
It's not so much the resource requirements, though. It's more about uptime. Like a seeder that is, 99.999% uptime is way more valuable than just 99%. It needs to be available almost all the time.
Yeah, but that's no problem for us.
Yeah. So if you can keep a node up and make sure it stays up for a long, long period of time, then that would be more valuable than having multiple, low quality seeders.
So just to check the requirements would be you run the seeder on the same machine that has a node, and the node has to have a high uptime. And the seeder
it doesn't require a node. Like the seeder is actually it's incredibly lightweight. It connects to other nodes as a node, I believe, and it doesn't need any of the consensus software at all. It's just maintaining a list of IPs. Very simple.
Yeah, it pretends to be a node, like in the sense it talks the same protocol as nodes, but it doesn't download the blockchain or validate anything. Mm-hmm. It's just, like collects 2 nodes and requests more nodes from them. And then, I keep a track of everybody and just, periodically go back to them to know, hey, are you still there? It does a few more checks, like, checking like what chain of header they follow, stuff like that. But it doesn't check much. It's very, very lightweight. Though you need to have a domain, obviously, to attach them to, and you need you need to be able to delegate a subdomain of your domain to some machine, because it actually acts as a DNS server, and you connect to it to resolve some domain, and it's gonna give you a list of IP, and that list of IP is a set of nodes essentially that the seeders knows about. And so you need to own a domain, and you need to not delegate the full domain to some third party. Like a lot of people use Cloudflare, for instance. You cannot really do that on your domain. You need to have the hand on your domain and be able to delegate like a subdomain to a name server of your choosing. That's going to be the seeder.
Okay. So that's the main trick then, is getting the DNS.
That's no problem.
Yeah. I see.
Okay, good. And that seeder software is included with the Bitcoin ABC releases. So just make sure people understand.
Yeah, there's a Bitcoin-seeder executable in there. This is what you want to be running. It doesn't work on Windows, though. You need Linux. It probably works on OS X, though. I don't know. I haven't tested it, so.
Yeah, I mean, just in terms of the concept of it, like, that's one of the it'd be nice to have a bunch of independent like entities running them, because that's like, as long as you have one good seeder, then you're okay on the network. So the more like independent people providing that, the better it is in terms of security.
Great, thank you for that discussion. Anything further that you guys would like to discuss? I have not seen any questions from the audience as of yet, but if you have anything further you'd like to talk about, we can do that.
I had one quick thing, which was maybe this is a good time to talk about when will the next upgrade happen? Do we still want to keep this 6-month cadence, or is it time to change that? We pretty much have to decide that also by the feature freeze date, right?
So we had a similar conversation before the last upgrade, and I think the general consensus was we don't really want to change the cadence until it's clear that we're starting to emerge out of the roadmap. That we're starting to check off most of those items, and I think it's way too early to start doing that. Even if that means maybe the next upgrade we don't have any like hard forking items, that would be okay. But we don't want to be changing the cadence and then later find out, oh, we actually would have benefited from going back to 6 months again, because flip-flopping is what's going to confuse businesses, and part of the reason that we chose the cadence is so that businesses can expect, every 6 months it happens. They should be upgrading their software around that time period. And if we start changing the expectation and then going back, that's when we start adding to the confusion. It's not worth it.
Fair enough. Yeah.
I'm having no questions from the audience, so I'd like to thank you all for attending today, and look forward to producing the video that will be sent out on the interwebs. So, thanks again, guys. Talk to you all soon.
Bye.
Thank you, everyone.
Ciao.
Bye.